In today's lesson, we're going to talk about internet fundamentals. And when we discuss internet fundamentals, we're talking about just, the basics of how internet's set up. I mean, we take it for granted, this thing we just turn on or we connect and we're automatically connected. But there's a lot of things that go behind the scenes that you need to know about. And the first thing we're going to talk about is, network fundamentals. So how is a network set up? Topologies of a network, what is a backbone, and things like that. So why don't we do a basic network overview? And when we talk about a network, all we're really saying is a network consists of two or more computers connected for the purpose of communicating and sharing resources. And these two computers can do anything, right? They can be sharing data with each other. In fact, if you're ever in a room where you just have no internet, but you have a bunch of computers stacked on a network topology where you're just sharing information, that could be considered a network also. So a network isn't simply just the internet. And we have common components of networks. So we have server computers, client workstations, shared devices, routers and hubs and switches and things like that. And all the media that connects them. And when we talk about the media that connects them, we're not just talking about some video. We're talking about the physical or the wireless media that connects them. For instance, networking cable or the microwave transmission between two dishes. So those are networking devices. For example, take a look at this illustration. We have a bunch of workstations and printers and routers. They're all connected to switches, and then we have the internet. Every time you look at any diagram of what the internet is, it's basically drawn as a cloud, and it's got like a little lightning symbol or whatever that connects to the internet. Because the internet is not one thing. The internet is basically a bunch of distributed networks. We connect to these servers, and then we connect to the internet, or we connect to servers through the internet. Let's talk about clients and servers. So when we think about a client, these are the computer workstations that you typically use. For example, your cell phone, it's a client. The Chromebooks you use, client, things like that. We're all receiving data from a server. So if you think about a client and you think about the data that you receive, for example, like whenever you play an online video game or whenever you check Instagram or whatever the case may be, you're pulling data from a server through the internet, and then that shows up on your client device. Without the internet, without a connection, those devices are useless, right? For example, like a Chromebook. The functionality of a Chromebook is severely limited if you don't have a network connection. That means you can't pull your synced files on Google Drive. You can't watch videos on YouTube. You can't do a lot of things if you're disconnected from the internet. All of that data simply does not exist. You're working either with old copies or you're working with an unsynced copy because you're not connected. So your Chromebook and your cell phone and things like that are just simple clients. Even like newer video games now, if you're on Steam or if you're on the Epic Game Store, a lot of those games won't run, especially if it's games as a service. For example, like The Division 2 or I want to say Destiny. Anyway, a lot of games won't work or a lot of the functionality just won't work because you're not connected. So that is a service. You're a client-side service. So all a server is a type of computer, usually a very high-speed, very powerful computer that gives you information, that feeds and facilitates information. And computer user servers are usually protected and in a secure area, and they're locked down. Like if you ever went on YouTube and you looked at servers behind secure facilities, they have lasers in the floor to detect pressure. Could you imagine what kind of damage that could happen if someone got into a server room, right? You could really affect a lot of things. So servers are usually kept in secure areas and they're only accessed by network administrators. So when we talk about different server types, we can talk about, your YouTube video server, your Discord server. All of these things turn into servers. And you might be asking yourself, well, I thought you just told me servers have to be in secure facilities. It's very expensive to run a server, if you think about it, right? If you have a very popular server that everyone's connecting to, you're going to have bandwidth limitations. That means you're going to have a lot of information that can't be facilitated. You can't give out this information because, imagine it like a freeway. Imagine it like a road, right? And so if you have your residential internet and usually you have a high download speed, but you usually have a very slow upload speed, and you can imagine it as a single lane, right? So if you have 1,000 people per second that want to access your information, you have to spoon feed this information one at a time or one car at a time on this single lane road. But imagine if you had high speed upload capabilities like commercial internet. then that means you have like an 8-lane freeway that can facilitate the same amount of traffic a lot faster. Another type of server that we could talk about is like, video game servers. Every time you go to Google Drive, that's a server. Every time you check your email, that's from a server. So there's a lot of different servers out there, and I want you to think about that for yourself, especially if you're in my class and I'm giving you a quiz later. All right, let's talk about LAN and WAN. So LAN stands for a local area network, and if you think about a LAN, you want to think about just a single wired up building, right? That would be your LAN. If you work in office, you probably use a computer connected to a LAN. So in this school, like if you're connected, you're on a big local area network connected to a wider area network, but we'll talk about that later. But let's talk about LAN topologies. So if you want to think about topologies, the most common topology we use is a star topology. And here's why. So here's a map of network topologies, and let's start from the upper left and go to the bottom right. And to understand how this works, we have to look at these computers. So every time I make a request, I send a token out, which means I send a request out like I'm looking for you, right? And so in all of these topologies, except for the star, right? So we have fully connected, mesh, common bus, ring network. That means I'd have to send a token out and say, are you this person? No. Are you this person? No. Are you this person? No. And then we'd work our way back. The problem with all of these topologies, with the exception of the star network topology, is that it's relatively slow and it's outdated. Now imagine that you have all these wires coming out of your computer and you're connected. It's so hard to keep track of everything. It's so many wires, right? And I have to send out tokens to every single computer just to look for the person I'm trying to look for, so they can send me a token back saying, here I am. Here's another problem with this. Let's take a look at the common bus topology on the bottom left. Could you imagine if you cut that main line? That means half that network won't work because you can't send signal. The signal doesn't bounce back. You have a dead network. That is to say, in every single one of these networks, except for the star topology, if any one of those computers goes down, odds are the entire network goes down. So it's very inefficient. But let's look at the star network topology. You can see that every single computer is connected to a router, and that router is connected to the internet. And this is great, because if one computer goes down in the star network topology, the other 4 computers will still work because you can still connect to the router. Now, if the router's down, well, that's not a problem. Everyone can clearly identify that it's the router issue, and you can either reset or replace the router. So this makes connecting very easy, and this makes connecting on this network a lot more efficient. And here's a sample LAN network topology. We have a bunch of things connected to a hardware access point, and then that access point goes to a computer with a software access point, and then we go to another wired network. Now let's talk about the wide area network, the WAN. So you can think of a WAN as geographically dispersed. So for instance, if your local network, like your office building, has wired up computers and you're trying to connect to somewhere that's hundreds of miles away or thousands of miles away, you can still do that because we're just firing information over fiber optic cable, or we're just firing off information via microwave. We can still communicate, but we're on the same network, and that's great. That means I can distribute my network across wide areas. And here's an example of a WAN. We have 2 separated cities, and there's a bunch of routers connected in between to facilitate this WAN. We can connect one side with the other side, and we're all sharing information on the same network. And the interesting thing about a local area network versus a wide area network is that if one side goes down, the other side can still function. That's not a problem. So when we talk about local area networks, and if you want to think about like in the 90s or in the early 2000s when people, even in the 80s, when people wanted to play online games or wanted to network games, people physically brought their computers to a house to play because we'd all hook up on a giant LAN. Like I used to play Quake a long time ago in network days, and we used to just kind of everyone brought their computer over, we hooked them all together on a giant LAN, and then that's how we played. So that's where LAN party comes from. Like if you ever heard the term LAN party, that's where it is. You all came over, you brought your party snacks, and then you just had a good time. All right, so now let's talk about backbone. So all a backbone is high capacity comm link. So you can think of the backbone as like fiber optic cable. And by the way, fiber optic cable is pretty cool because it's flexible glass that we transmit light through, right? So if you can think about bits and bytes, zeros and ones, things being on and off, all we're doing is flicking light on and off trillions of times a second, and then through fiber optic cable, through glass. And all of these cables actually run under the ocean. I'll show you a map later. So on the internet, we think of a backbone as a set of paths or local regional networks that connect, that we connect to for long distance communication. And the internet is all the internet is a group of interconnected networks. Like I said before, all it is a group of interconnected networks with high-speed connectivity provided by the internet backbone. And this is the question. So what are internet backbone underwater cables? And so if you wanted to like go on the internet or just open up another browser tab and then go ahead and search up what an underwater cable is, or undersea internet fiber optic cable, and then if you can pull up a map to it. I think I have a map. I'll post it up on the screen right now. So this is a map of undersea cables, and if you think about it, it runs through every single country. It runs across the Pacific Ocean, across the Atlantic Ocean, and this is awesome. I mean, you don't know that it's underwater, right? It's just there. In fact, it was a long time ago, maybe like 6 or 7 years ago, in the Mediterranean, there's a lot of cables, and some ship dropped anchor in the port, and the anchor was so heavy that it cut one of the undersea fiber optic cables and then knocked out internet to like half of North Africa. It was amazing. Like something that easy could knock out internet for that many people. So yeah, those are undersea network cables. Okay. If you have any questions, go ahead and post them up. Email me, sure. Comments, sure. And then, if you have any questions, just let me know. All right. I'll see you later. Bye.